In this video, we will know about sacrificial and isovalent hyperconjugation. Hyperconjugation is known as no-bond resonance. In another term, it is known as Baker-Nathan effect, also. This name is given in the name of the duo scientists. With the help of hyperconjugation, we can explain the stability of carbocation and different radicals. Now, we will know the concept of hyperconjugation. That very process is hypothetical in nature. It is assumed that alpha hydrogens are eliminated out on the breakage of carbon-hydrogen sigma bond and shifted to the adjacent bond to form a new pi bond. In this concept, we have to consider the neutralization of positive charge, present in the carbocation. Similarly, the detouched hydrogen will get positive charge. We will have to keep in mind that the more the number of hyperconjugative structure, more will be the stability of carbocation or radical. Now, compare among ethyl carbocation, isopropyl carbocation and tertiary butyl carbocation. We draw the respective hyperconjugative structures. First one will give 3 structures, while the second one will give 6 and last one will give total 9 structures. From those hyperconjugative structures, it can be easily concluded that 3-degree carbocation is most stable while 1-degree carbocation is least. Now we will know about the sacrificial hyperconjugation. If the total number of sigma and pi bonds become less hyperconjugative structure than the original structure, then it is known as sacrificial hyperconjugation. That type of hyperconjugation is observed in case of alkenes or alkynes where sp3 carbon is attached with sp2 or sp carbon center. In the given example, we can observe that the number of total bonds in hyperconjugative structure is less than those of the original structure of the species. In the given example, the total number of bond in the original structure is 9. While, in the hyperconjugative structure, total number of bond is 8. So one bond is being sacrificed in the hyperconjugative structure. That is the unique example of sacrificial hyperconjugation. Now, we will know about iso_valent hyperconjugation. In that case, the total number of bonds remains same in original structure and the hyperconjugative structure of the species. This type of hyperconjugation is observed in carbocation S. In the given example, total number of sigma and pi bonds are 6. It is observed that in the hyperconjugative structure, the total number of sigma and pi bond is also 6. That is, there is no change in the number of bonds. So, no sacrifice is done here. This type of hyperconjugation is known as isovalent hyperconjugation. Our today's lesson is complete. For more contents like this, like and subscribe the channel.